Lecture 7.4, Day 2, Surface Area. Consider a curve rotated about the x-axis. The surface area of this band is 2 pi r ds, that is the circumference times ds. The radius is the y value of the function, so the whole area is given by the integral from a to b of 2 pi y ds. This is the same ds we had in the length of curve formula, so the formula becomes surface area about x-axis, Cartesian, s equals the integral from a to b, 2 pi y times radical 1 plus dy dx squared dx. To help remember the formula, remember that this is just the circumference, which is 2 pi r, or since r is y, or y is r, it's 2 pi y, times the length of the curve. To rotate about the y-axis, just reverse x and y in the formula. Rotate about the y-axis. The equation of the line is y equals negative 4/3 x plus 4. When we rotate about the y-axis, we get a cone. We solve for x. Y minus 4 equals negative 4/3 x. Negative 3/4 y plus 3 equals x. X equals negative 3/4 y plus 3. So that will be the radius. Dx dy equals negative 3/4. So s equals the integral from 0 to 4, 2 pi times x, which is negative 3/4 y plus 3, times radical 1 plus negative 3/4 squared dy. Negative 3/4 is, of course, dx dy. Which is the integral from 0 to 4 of 2 pi times negative 3/4 y plus 3 times radical 25/16 dy. We can factor out the 2 pi as a constant. So it's 2 pi times the integral from 0 to 4 of negative 3/4 y plus 3 times 5/4 dy. The 5/4 is also a constant. And then we take the antiderivative, plug in the limits of integration, and simplify to get 15 pi as the lateral surface area. From geometry, you may or may not remember the formula, but the surface area is pi r times the slant height. And since it's a 3, 4, 5 triangle, it's pi times 3 times 5, or 15 pi. Here is another example. Y equals radical x rotated about the x-axis. The surface area is 2 pi times the integral from 0 to 9 of y times radical 1 plus dy dx squared dx. In this case, y is the radius. We store the function radical x as y by entering radical x, control, store, y, enter. Then we enter the integral into the calculator. 2 pi times the integral from 0 to 9 of y times radical 1 plus d dx of y, quantity squared, dx. We hit control enter, and our answer is approximately 117.319. And another example. X squared plus y squared equals 1, rotated about the x-axis. This is the equation of a unit circle, but we are only going to look at the top half. We solve for y and get y equals radical 1 minus x squared. So the surface area is 2 pi times the integral from -1 to +1 of y radical 1 plus dy dx squared dx. We'll store radical 1 minus x squared as the y. Then we enter the integral. 2 pi times the integral from -1 to 1 of y radical 1 plus d dx y, quantity squared, dx. We hit control enter and we get approximately 12.566. Using our formula from geometry, the surface area of a sphere is 4 pi r squared. But in this case, r is 1, so the surface area should be 4 pi. If we convert that to a decimal, we get 12.566, which is the same answer we got previously. Again, don't forget to clear the x and y variables when you're done. We use menu 1 for enter.